Hello YouTube. Tonight I wanted to talk a little bit about computer numbering systems and how it really works. How to understand it, just the simple basics. As you know, we have many numbering systems. We have our day-to-day numbering system, which is base 10, if you know what I mean. In other words, digits from 1 to 9, and 0, of course, makes 10. So we have base 10 numbering systems. There's binary numbering systems, which I won't get into. That's a little bit more complicated. I do understand it, but maybe I'll save that for a later video. But what I wanted to talk about was the numbering system called hexadecimal. What is hexadecimal? Well, hexadecimal is similar to our base 10 numbering system, but it's base 16. So just like our regular numbering system, hexadecimal does start off in 0. Okay, see that? 0. Same as decimal. And this holds true all the way through until you get up to the number 9. It's the same, whether it be decimal or hexadecimal. So 0 to 9 in hex looks the same as regular numbering system. However, when you get to 10, things change. Now 10 becomes the letter A. 11 becomes the letter B. And so on and so forth. 13 is C. Next number is D, and then E, which is, I believe, 15, right? 9, 10, 11, 12, 13, 14, yeah. I'm sorry, 15 is F. Yeah, 9, 10, 11, 12, 13, 14, 15. So 15 in hexadecimal is the letter F. Well, you might say, well, what happens after 15? Then the number rolls over to, what is it, 1, 0. Right? So after F, it becomes, or OF, if you want to add the nonsense 0, it becomes the number 10. That would be number 6. 10 is equivalent to 16 in hexadecimal. But then again, the process starts repeating itself all over again. In other words, it'll be 1, 0, 1, 1, 1, 1, 1, 2, 1, 3, 1, 4, all the way up to 1, 9. When you reach 1, 9, then it becomes 1A, 1B. See what I'm doing here? So now you're using all these extra digits that we normally don't have in our numbering system. After you hit your 9, you go A, B, all the way up again to 1F. Okay, just like that. Where does it go from 1F? It goes to 20 or 20 in hexadecimal. So that's basically how the hexadecimal system works. You got to remember something. For every second digit, that equals 16. Okay, that's a 16 multiplier. If it's a 2 here, that's 2 times 16, which would be down here, which would be 32. 20 in hexadecimal is actually equal to 32 in decimal. Yeah, if you can reconvert it to decimal. So 20 equals 32. You see the advantage of this. The advantage is you're not using all these numbers that were base 10. Now we're in base 16. But if you think about it, you could use any base you want. You know, you could use our whole alphabet as your base. What would that be? Base 26 or 27, whatever it is. Is it 24? I forget how many letters are in the alphabet. I don't remember that. I'm sorry. I'm not trying to be silly, but I just simply don't remember that. Is it whatever. That could be your base. So, like I said, as you go along, the next number after 20 hexadecimal be naturally 21, and then all the way up to 29, and then again it would be 2A, 2B, 2C, 2C, 2D, 2E, 2F, and then it would become 30, which would be adding another 16 on to the 32. So that's how hexadecimal works. I thought you would like that. Next time we'll talk about binary. The first number in binary is all zeros. Okay? We'll leave it at that, and we'll reserve binary for another discussion. Thanks for coming along. Thanks for watching. Please subscribe, and we'll see you all again later. Bye-bye.